So this is how the FreeRTOS kernel fits in between your application and hardware. So this is a FreeRTOS kernel which is downloaded from freertos.org. Okay, so this FreeRTOS kernel consists of lots of kernel objects like semaphores, queues, timers, task, memory management, etc. So all these are kernel services. So these are all piece of code which actually gives lots of services to meet the real-time application requirements. You can use all these services. Okay, so each subsystem or each services provide its own set of APIs. For example, semaphore provides you its own set of APIs. The queue management service provides its own sets of APIs, so and so on. So all these APIs you can use and you can write an FreeRTOS application. So a FreeRTOS application, say application 1, can have n number of tasks. Okay, so each takes care of implementing some functionality, and the application actually uses FreeRTOS API. This is okay, FreeRTOS API to use its kernel services. Okay, and after that FreeRTOS talks to your device driver like UR driver, SPI driver, okay, etc., to talk to the hardware. Okay, the hardware usually consists of lots of peripherals like SPI, I2C, timer, GPIOs, etc. So FreeRTOS doesn't contain even single piece of code related to the hardware peripherals. Okay, it's a pure kernel code. Okay, so you have to fit in your BSP layer, or you can say the device driver layer, to make use of hardware. Okay, there are flavors of FreeRTOS which comes with third-party BSPs. So for that you have to check in the website. For example, see here FreeRTOS BSPs. So this page lists out the support for BSP and FreeRTOS. As I said, FreeRTOS is just a kernel without having any component of code related to MCU peripherals, drivers, or board support packages. So these links will guide you further about using FreeRTOS along with board support packages. In this course, I have thoroughly covered using BSP plus FreeRTOS on Atmel as well as on STM based microcontrollers. And if your microcontroller is based on, say, NXP, then also it's the same procedure and I don't think you will find any problem. Great. So to conclude this, your application consists of different number of tasks which does a unique functionality, and your task usually use the FreeRTOS exposed APIs to communicate with the FreeRTOS kernel. So the FreeRTOS kernel is actually, you download it from freertos.org, and it has lots of kernel services like semaphore, queues, timer services, etc. And each services exposes its own FreeRTOS APIs, and your FreeRTOS kernel actually need a device driver to talk to your hardware peripherals. Okay, this we usually call a BSP. Either it is developed by you, or usually the vendor provides you all the peripheral drivers and BSPs required for their microcontroller and board. Okay, so we will see how we can integrate the board support packages, the FreeRTOS, the application, everything in this course using Atmel Studio, Keel, as well as Eclipse based IDEs. Okay, so in the next lecture we will enter into one of the important lecture, that is FreeRTOS file structure and its hierarchy. See you in the next lecture.